Okay, so this is the presentation of the review for units 9 and 10, and when appropriate we need to give our angle measures to the nearest tenth of a degree, and I'd like all lengths to simplest radical form or 3 sig digs. So number 1, the sides of an isosceles triangle have lengths 5, 10, and 10. So I'm going to draw my typical isosceles triangle right here, and then the base of that triangle would be a 5, and then in the isosceles triangles the two legs are congruent, so that would be a 10 and a 10 right there, and then they're asking for the measures of the angles. Alright, now this is early on when we were doing right triangle trigonometry, so we're going to do this together that way using the right triangle trigonometry, but I hope you guys notice here that you do have side, 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 so you could find these angles with the law of cosines as well, or when you get enough angles you could also go to the law of sines. Alright, so I'm going to go ahead and label my vertices A, B, and C right here. Alright, and then I'm thinking right triangle trigonometry right now. So I'm going to put this height or altitude into my diagram, creating two congruent right triangles. There's my 90-degree angle right there. And right triangle trig, okay, this adjacent side right there, the distance from A to 5, well, that would be 2.5. Alright, and now I think about this, the 2.5 is adjacent to angle A, and the 10 is hypotenuse, so adjacent to hypotenuse, SOHCAHTOA. That's cosine of adjacent to hypotenuse. Alright, so I'm going to say cosine of angle A is 2.5 to 10. And you could simplify that if you want, but we're going to use a calculator so you don't have to. So now to find angle A, we're just going to go inverse cosine of both sides. So the measure of angle A is an inverse cosine of 2.5 over 10, and I'm getting 75.5 degrees. So make sure you're punching this out yourself and make sure we agree right here, because most of the mistakes we'll find on a test like this will be calculator mistakes. Punch out everything with me, please. So if angle A is 75.5, what would angle C have to be? Those are the base angles of an isosceles triangle. So angle C would also have to be 75.5 degrees. Base angles of any isosceles triangle are always congruent. And now we also have enough information to find angle B up here, that entire angle, by the triangle sum theorem. The measure of angle B, triangle sum theorem. Now you guys know that the three angles of any triangle add up to 180, so measure of angle B is going to be 180 minus the sum of our two base angles. So 180 minus, and if I add up 75.5 and 75.5, do we got a 151 right there? Okay, oh, I just did 2 times 75.5. And that's going to be, well, 180 degrees minus 151 degrees. That's going to be 29 degrees. And I did that 29.0 because they want this to the nearest tenth. All right. And, you know, if you had a 29.0 and you gave me just 29 degrees, that would be fine with me for full credit. All right. So that's number 1. Hope you guys enjoy this stuff. Right triangle trigonometry. Man, when you have right triangles, it's great stuff. Okay. Now, here's your story problem. At a distance of 100 meters, the angle of elevation to the top of a fir tree is 28 degrees. So they want you to diagram this. So here's my fir tree right here. And what? We are 100 meters from the fir tree, apparently on perfectly flat ground, by the way. So we're standing right here. And this distance to the fir tree is 100 meters, all right? And then about how tall is that tree? Well, they want this height right there, okay? And this is hopefully a right triangle, so we can use our right triangle trigonometry. And think about this now, okay? We want the height, which is opposite the acute angle we would have right here, and the 100 is adjacent, so I'm thinking opposite to adjacent. What are you thinking? I'm thinking about tangent. So this angle right here is 28 degrees. So can we go tangent of 28 degrees would have to equal h over 100? Well, SOHCAHTOA, see that tangent is opposite to adjacent right there. So tangent of 28 degrees is h over 100. And now one step, let's just multiply both sides by 100. So h is approximately 100 times tangent of 28 degrees. And if I punch that out, (100) tangent of 28 degrees, and that is a length, so I'm going to go 3 sig digs, and I'm getting 53.2. 53.2, and do I have a unit? Yeah, well, this is in meters, so that would be 53.2 meters. And there's your second problem right there. Great, right triangle trigonometry is solid stuff. All right, now, I like this problem. So, a regular pentagon, that's not a right triangle. What are we going to do here? Is inscribed in a circle of radius 4. So let's draw a picture of that. This is a regular pentagon, and a regular pentagon is a pentagon that is equilateral and equiangular. So all of those 5 angles would have the same measure, all right, and each of those side lengths would have the same length. But what are they doing? We want to find the area of a pentagon, all right? How do you find an area of a pentagon? Well, they did say it's inscribed in a circle with a radius of 4. So let's put that inside a circle, and let's give that circle a radius of 4. So you'd need the center of a circle, and then you've got the radii. I'd probably put it in some strategic places, like maybe right there. All right. And now, you know, we've been working with triangles, and all of a sudden on the review, they throw a pentagon at you. Well, we could triangulate this pentagon right here. So, congruent isosceles triangles and K given side angle side. So do you see what I see? I see 5 congruent isosceles triangles, and I know that each of these lengths right here would be the radii of the circle 4. So that's a 4 too. Now, how are you going to find this angle right here? Well, let's see. What's one complete revolution? 360? And there's 5 congruent angles that make up that 360 degrees. So what I'm going to do is go, what? 5, let's think 360 degrees divided by the 5. And what's 360 divided by 5? I think it's 72, isn't it? Yeah, 72 degrees. So that included angle is 72 degrees. And now what do you have? You have enough information to find the area of this isosceles triangle right there, because you have side angle side, excuse me. So remember your K now. Well, let's see. I'm going to use a capital K for the entire pentagon, and that would be the area of the entire pentagon would be the area of these 5 congruent isosceles triangles. So can I call that 5 lowercase k? And do you see what I'm doing right here? Lowercase k is the area of each isosceles triangle. I have 5 of them, so 5 times that k will give me the area of the pentagon. And now we're simply using our area of a triangle when we have side angle side. And that, of course, is your general formula, 1/2 AB sine of, and sine of what? Your included angle C right there. So let's go. So let's go 5 times to 1/2, and my A and B are these 4s, so I could go 4 times 4 or 4 squared or 16, whatever you want to do. I did a 16 there. And then sine of that included angle, which we discovered was 72 degrees. So let's punch that out carefully. And you might simplify, you know, half of 16 times 5, something like that. Do whatever works best for you. So I'm going to go 8 times 5 is 40, 40 sine of 72. 40 sine of 72 degrees. And what do I have right there? And this is an area which we're also going to go 3 sig digs. So I am getting a 38.0. 38.0, and check, do we have units? Yeah, the radius is 4 inches right there. So the area of this entire pentagon right there would be 38.0 square inches. And if you just wrote a 38 there, that would be fine with me. So this area of a triangle given side angle side, you have a lot of use for that. All right. Without that, remember in geometry you had to find the apothem and all that stuff. There's a lot more work. Okay, number 4. Find the angle indicated. Be alert to problems with no solutions or 2 solutions. All right. Notice how I gave you this broken triangle as the diagram right here, because I bet you they're going to give us side-side angle here. So side P is 5. Side Q is 4. All right. And then angle Q is 74. And then they want us to find this angle P, and given side-side angle, you know, angle P might not exist. Angle P might be a 90-degree angle, or there might be 2 possible angles for angle P, one acute and one obtuse. So we've got to be aware of that when we have that side-side angle stuff going on right there. All right, law of sines then. Side-side angle, I'm using law of sines. So let's go. And we're looking for angle P if it exists. So I'm going to start with a sine of angle P over the side opposite that angle, which would be 5. And then can I go sine of the known angle, 74, over the side opposite that 74, which would be a 4. And now let's just multiply both sides by 5. So sine of P equals 5 times sine of 74 over 4. All right. Now 5 times sine of 74 over 4, I think that might be a little more than 1. And I could do that in one step. I could punch that out and check it out, or I could just do inverse sine of that right-hand side right there, and my calculator might give me an error. Let's try that. Let's do that. Let's pretend like we think that 4 might actually create a triangle. So I'm going to go second inverse sine, second sine for inverse sine, and then I've got 5 sine of 74 divided by 4. Double check my calculator. Inverse sine of 5 sine of 4 divided by 4. And I'm thinking my calculator is going to say error, but I might be wrong. Oh, hey, it worked. I got a 5 right there. Okay, so angle P, let's see, inverse sine of, and I'm getting a 5 right there. Hang on, let's think about this. 5 sine, oh, I know what I did. I made a mistake on my calculator. I didn't double check carefully. Okay, let me punch that out one more time, you guys. And I put a 4 where I needed the 74. Second insert 74. Okay, now, yeah, and I'm getting the error there. All right, so this angle P does not exist. Okay, so 5 sine of 74 divided by 4, 1.20, and that's why, because this is greater than 1, and you guys know sine oscillates between -1 and +1. So angle P does not exist. Okay, there you go. You could say or no solution, either way. Okay, let's move on to number 4B right here. And I had to put a little note, this is not the scale at all right here. But again, just label everything and do your thing. So now this time, my P is 9, so that'd be a 9 right there. My Q is an 8 right there. And my angle P, which is broken in my diagram, but they say it's 23 degrees. And obviously, if that were not broken, that would not be close to 23, but just label everything. And we're looking for angle Q. So again, we have side-side angle. Okay, angle Q. We're going to use law of sines. So we're trying to find Q, so let's start with a sine of Q over the side opposite that Q, which is 8, has to equal sine of the angle we know, sine of 23, over the side opposite that 23 is a 9. And now let's multiply both sides by the 8. So we have sine of Q equals 8 times sine of 23 degrees divided by 9. And And now you're just going to go inverse sine of this side over here. So the measure of angle Q is, and let's be careful on our calculator. All right, so let's go second sine for inverse sine of 8 sine of 23 degrees divided by 9. Double check that. Inverse sine of 8 sine of 23 degrees divided by 9. There we go. So my angle Q to the nearest tenth, I'm getting 20.3. 20.3 right there. All right, so there we go. Number 4. Okay, now let's be aware of this because this is side-side angle right here, correct? So that 8, remember that hinge stuff going on? Could we also get an obtuse angle here? All right, so you know what you need to do now is draw your unit circle. And there's my unit circle right there. And I'm going to put an estimate of 20.3 degrees, about right there. And now I'm thinking sine, right? So isn't sine also positive in quadrant 2? So let's reflect this ray in the y-axis to get that ray. And that would be 180 minus the 20.3, which is that what? 159.7? 159.7. Now, you guys, why is that in black? Well, look at the angle I know about, the 23 degrees. Can I have a 23 degree angle and a 159.7 degree angle in the same triangle? I cannot, because the sum of those two angles is greater than 180. All right, so the only answer here is the 20.3. Okay, so number 5. Observers at a point A and B 30 kilometers apart. So let's draw that. There's A and B, and that is 30 kilometers right there. Sight an airplane at angles of 40 and 75 degrees respectively. So let's put this airplane above the segment AB somewhere, about right there, and then create our triangle. Oh, nice. And let's see, can I call angle A the 40 degree angle and call angle B the 75 degree angle? Now, how far is the plane from each observer? All right, well, let's see. I see angle, side angle. So I think I can find those distances with the law of sines. Yes, angle, side angle, law of sines. Okay, so triangle sum theorem. Let's find that third angle. All right, so let's see, 40 and 75. Well, that would be what? 100 and... Actually, 100. I'll tell you what, I better have a little more coffee. Let's see, 40, 105, 7. Yeah, there's 180 right there. So this is 65 degrees right here. Okay? All right, now let's find A. Okay, so A. Well, can I use my form where I'm going to go reciprocals, proportions right there, and start with that side A over sine of the angle opposite A, which would be 40 degrees, equals, and now let's go the 30 kilometers, 30, and this is why we needed this third angle right here, sine of 65 degrees. All right, so to find A, it's one step. Let's multiply both sides by sine of 40. So A is, all right, so I'm going to go 30 sine of 40 degrees divided by sine of 65 degrees. And I am getting the 3 sig digs at 21.3. Let's see, how do we do here? Oh yeah, 21.3 right there. And do I have any units here? Well, this is kilometers, so that'd be 21.3 kilometers. So that jet right there is 21.3 kilometers from that person standing at point A right there. All right, now we'll do the same thing to find this distance over here, B. All right, so let's set it up, and we're going to go B over sine of the angle opposite B, 75, equals, and let's use the stuff we know again, the 30 over the sine of the 65-degree angle right there. And now let's multiply both sides by sine of 75. So sine, let's go 30 sine of 75 divided by sine of 65. And this one, to 3 sig digs, I'm getting a, well, that 9 would go to a 0. So is that 32.0? 32.0 and 32.0 what? Kilometers. All right, number 5. Now, the way this problem is written, all right, you realize that you could have saw this picture a little differently. What if this plane was over here to the right farther? So if you saw it like that and did it like that, I'd have to give you full credit. And I want to show you what that one would look like right there. So here's my AB right here of 30 kilometers, but if the plane is over here, I've got the 40 there, and I've got the 75 right there, and then you've got to find the 105 right there, and you get it that way. Totally different answers, all right? But both of these are very appropriate for that problem. I think the way we visualized it was a little simpler, but both would work. Okay, so number 6, a triangle has sides of length 5, 8, and 10. So that's a scaling triangle right there. So not perfect, but let's go ahead and put our dimensions in. So the shortest side is 5, so I'd probably put that right there. The 8, well, let's see, probably the 8 I bet you right there. And here's my 10. Okay, so what is the measure of its largest angle? Well, from geometry, we're hoping you remember that the largest angle would have to be opposite the largest side. So we're looking for the measure of this angle right there. And I'm going to call that x. Okay, now I have side, 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 and I'm looking for an angle. Doesn't side, side, side imply law of cosines? Law of cosines right there. And we're looking for an angle here, so let's go the cosine of, and let's go general right here. So cosine of C equals a squared plus b squared minus c squared over 2ab. Now remember, this isn't labeled with an a, b, and c, so you've got to know what these all mean here. Now, the x is our angle, so let's go cosine of x equals, and then the a and the b are adjacent to the x, so a squared, did I go 25? B squared, did I go 64? Minus c squared, the opposite of the angle I'm finding, 100, over 2 times a times b, 2 times 5 times 8, or 2 times the 40 right there. All right, and now you're just going to go inverse cosine of everything over here on the right. So x is approximately second inverse cosine of, careful with your parentheses now, 25 plus 64 minus 100, 25 plus 64 minus 100. And that quantity, 25 plus 64 minus 100 divided by the 80. All right, double check. Inverse cosine of 25 plus 64 minus 100 over 80. Yep, that's it. All right, and that is an angle. So to the nearest tenth, let's see. Are you guys getting 97.9 degrees? 97.9 degrees right there. Okay. Oh, is that all they asked? Yeah, they just asked for that largest angle, didn't they? I thought we'd go ahead and find the other two, but let's move on because they just asked for that largest angle. All right. Hey, that diagram wasn't too bad either. I don't know. That's a little short. That looks more like maybe a little less than 90, but I did my best. All right. Number 7. 2 hikers follow a trail that forks. So I'm just going to draw a fork and a trail. There we go. Notice everything perfectly straight too. That always happens in the woods now, doesn't it? Now, each hiker takes a different fork, which you're breaking the rules of hiking in the woods, by the way. So the forks diverge at an angle of 67 degrees. So this angle right here is 67 degrees. And both hikers walk at a speed of 3.5 miles per hour. How far apart are the hikers after 1 hour? Well, if they're walking at 3.5 miles per hour for 1 hour, that would make this distance 3.5. And this distance 3.5. And how far apart are these hikers? That far right there. Man, they don't watch the scary movies in the woods, do they? All right. There's also wild animals and stuff. All right. Stick together in the woods, you guys. Anyway, what are we going to use to find this D? Well, we have side angle side, so I'm thinking law of cosines. What do you think? So side angle side, law of cosines, and I'm going to use our original formula for law of cosines because we're looking for this length right here. And let's go general at first. So isn't that going to be c squared equals a squared plus b squared minus 2ab, and then cosine of that angle c. It is right here, okay? And the beauty is, you know what those all mean, so we can easily substitute. So c is the side we're looking for, so we're going to call that a d, and go d squared equals, and the a and the b are adjacents to the angle that we know about, so that would be 3.5 squared plus 3.5 squared minus 2 times 3.5 times 3.5 times cosine of 67 degrees. All right, and we're just going to take the square root of that entire right hand side. So d is, let's punch this out with me. I better charge my batteries. I've been using this calculator a lot lately. Second square root of 3.5 squared plus 3.5 squared minus 2 times 3.5 times 3.5 cosine of 67 degrees. All right. I wish I could see that whole thing on there, but I'm going to trust I did it. We'll catch it if I didn't. All right. And, okay, what? I am getting, now this is a distance, so I'm getting 3.86 to 3 sig digs. So let's see how I did. Yeah, 3.86 right there. So 3.86, and double check, do we have a unit? Well, this was miles per hour, so that would be 3.86 miles. All right, those two hikers are way too far apart in the woods. All right, number 8. Here's your general rule that I've been verbalizing almost every day. When only 3 parts of a triangle are known, the law of sines and the law of cosines can be used to find the unknown parts. Discuss the specific circumstances for using each law. And here it is in a nutshell. And I give you a piece of paper with more detail, but keep it simple. Essentially, if you have 2 angles or side-side angle, you're going to use law of sines. So, let me see. I wrote this the other way. So side angle side or side side, I'm law of cosines. Anything else, law of sines. And remember, side angle implies we could have 0, 1, or 2 triangles. All right, awesome. Okay. Now we're getting into the chapter 10 stuff. Oh, this is so cool too. And look at this very first problem. Let's simplify cosine of 75 degrees times cosine of 15 degrees plus sine of 75 degrees times sine of 15 degrees. All right. And, you know, by the way, if you just punch this out and give me an approximation, you're not going to get a lot of points because with your angle addition formulas, you can get exact answers here, and that's what we're looking for. All right, so let's see. Cosine, all right, I think we're going to use cosine of alpha minus beta right here. And you see how I did that right here? Here's my sum and difference formulas for cosine and sine. And look at that, cosine of alpha plus or minus beta. What I recognize is cosine. So I know I'm going to use this top one right here. And the key is this, you guys. you're going to go cosine, and your two angles are 75 and 15. Now, is this going to be a plus or a minus? And look at the notation. Plus, minus, and over here I have a minus plus. All right? So if this is a plus, that means this would have to be a minus right there. And I'm going to highlight those right there, like that. Okay? So if I have a plus here, I'm going to have a minus there. So this becomes cosine of 75 minus 15, which is cosine of 60 degrees. And then look, Mom, no calculator necessary. You might visualize the unit circle. All right, 60 degrees, well, that's right there. And cosine of that 60 degrees, well, this distance right here, the horizontal, that'd be 1/2. So there it is, number 1. Number 2, well, it's the same type of problem, but notice this one, sine times cosine, cosine times sine. We're going to use our angle addition formulas, but this time we're going to use the one for the sine, right there. All right, so let's get it set up. Sine of, and again, my two angles are the 75 and the 15. All right, but you see that we have a plus right there? Remember what I said? Sine remains the same. So with that plus right there, if I go down here, yeah, the sine remains the same. Boom, plus here means a plus between my angles. Plus right there. So that's just sine of 90. And sine of 90, of course, is 1. And if you need to visualize it, here's your 90-degree angle right there. And this vertical distance right here is exactly 1 unit on the unit circle. So there's number 2. All right, look at number 3. Cosine of 30 plus x plus cosine of the quantity 30 minus x. Wow. Now, when somebody looks at this, how do you simplify that? All right, let's make this really easy. Isn't this cosine of alpha plus beta? And then cosine of alpha minus beta? Can I use my angle sum formulas there? So the sum and difference formulas for cosine and sine right here. And I'm going to use that cosine. I'm going to use it twice here. So first let's simplify this first one. Cosine of 30 plus x. Well, that's going to be cosine of 30, cosine of x. And you guys know if this is a plus, I'm going to put a minus right here. I see that plus, I look at my formula, and they're opposite. That's a minus. All right? And then I've got to go sine of the 30, sine of the x. And now let's simplify this, because 30 is a pretty key angle, isn't it? Okay. Oh, let's get the other part done there first. Okay. So now these first two terms are the cosine of 30 plus x, and then let's go plus, and then let's go cosine of 30, cosine of x, and now I got a minus right here. That means I'm going to put a plus right here. There it is. And then I've got my sine of 30 and my sine of x. Just like that. Okay. Now, it looks a little complicated, but you're going to see there's things that cancel and there are like terms you can combine. So first, negative sine of 30 sine of x, positive sine of 30 sine of x. I'd cancel those two terms. Okay. And why did I break this out already? Okay, I'm going to clean it up. Oh, I know what I'm doing. I'm gonna substitute right now, and then I'll cancel. Okay, cool. All right. So what is cosine of 30? Well, you guys know cosine of 30 is a √3/2. And you see it right here. There's your angle, and this horizontal distance right here is exactly √3/2. All right? And then you've got your cosine of x, and then minus sine of 30. Well, that would be this vertical distance right there, which is exactly 1/2. Minus 1/2 sine of x. Okay, plus cosine of 30 again, plus the √3/2 cosine of x, plus the sine of 30, which is the 1/2, and the sine of x. Now let's cancel them here. All right, so equals, and now this is negative 1/2 sine of x plus 1/2 sine of x. Those are gone. And I have √3/2 cosine plus another √3/2 cosine, which is going to be √3 cosine of x. Combine those two right there, and there's number 3. How cool. Okay, I'm going to check on my class again. All right, hope you guys are enjoying this. Okay, so this is like the previous problem, except now we're going to use sine of alpha minus beta and sine of alpha plus beta. So right down there. Okay, so sine of 45 minus x would be sine of 45 times the cosine of x. And remember your Led Zeppelin, the sign remains the same. So you see that minus right there? We have a minus right here. And then you're going to go cosine of 45 degrees and then the sine of x. And let's go ahead and bring this minus down now. And notice the brackets, so I remember to distribute that minus to everything when I expand this. So this is going to be sine of 45 degrees, cosine of x, and then a plus again, plus cosine of 45 degrees, sine of x. Okay, so I think I'm not going to do substitution yet. I'm going to see if I can simplify and cancel right now, because I see a sine of 45 degrees cosine of x right there, and a negative sine of 45 degrees cosine of x right there. So that's going to leave me, and look what I have left. Negative cosine of 45 degrees sine of x, and then another negative cosine of 45 degrees sine of x to get negative 2 cosine of, let me go back, negative 2 cosine of 45 degrees sine of x. Now let's find our cosine of 45 degrees, which you guys know cosine of 45 degrees is root 2 over 2. And you'll see that right here. This horizontal distance right here is exactly root 2 over 2. Okay, cool. So, well, looks like if we cancel those 2's, we have our final answer right here. Negative root 2 sine of x. Great. Okay, number 5, find the exact value of cosine of 15. And this is what all these new formulas are all about. It used to be our key angles were like 0, 30, 45, 60, 90, and so on. But now with our angle addition formulas and such, we can find exact answers for stuff like cosine of 15 degrees. And remember, you could approximate that with your calculator, but not get the exact answer, and we are looking for the exact answer here. Okay, so cosine of 15 degrees. Well, I'm thinking about my cosine of alpha plus or minus beta. Cosine, and then I'm thinking key angles that I do know that I can add or subtract and get 15 degrees. Could I go 45 degrees minus 30 degrees? Do you guys agree that's 15? Okay, cool. So now let's use this. So cosine of 45 degrees. I'm sorry, but there's people in the hall being absolutely loud. Let me give it a second here. Wow. Okay, we're ready to go now. Lunch just got out. I'm so sorry. But that's cosine of 45 degrees, and then you're going to have a cosine of 30 degrees. And now this is a minus, so I'm going to need a plus right here. And that's my rule down there. If I see a minus here, I look down here, and a minus there gives me a plus right there. So a plus, and then we're going to go sine of 45 degrees and sine of 30 degrees. Now, we know all these outputs, so we're ready to finish this problem. Equals cosine of 45 degrees. Again, that is root 2 over 2. And for your visual people, here it is right here, and that horizontal distance right there is root 2 over 2. And then cosine of 30 degrees, well, that angle's right here. And this horizontal distance would be root 3 over 2, exactly, plus, and then the sine of 45 is this vertical distance right here, exactly, root 2 over 2. And the sine of 30 is this vertical distance right here, which is exactly 1/2. Okay, let's clean that up and we're done. So that equals, do you see the common denominator of 4 in each of those terms? And then root 2 times root 3 is root 6 plus, and root 2 times 1 is root 2. So root 6 plus root 2 over 4 is my exact answer. And I'm sorry, you've got great calculators, but your calculator will not give you this answer. Okay, number 6. find tangent of 5 pi over 4 minus theta. And they did give us that tangent of theta is negative 1/3. So we just need our sum and difference formula for tangent. Here it is right here. Tangent of alpha plus or minus beta equals tangent of alpha plus or minus tangent of beta over 1 minus plus. Remember what that notation means? Tangent of alpha times tangent of beta. So let's go to work here. All right. Tangent of 5 pi over 4. Okay. And let's see, we have a minus here, so I need a minus there. And then tangent of theta, or I could put negative 1/3 in right now. Tangent of theta. Okay. All right. And then I've got a 1 and a plus, because this is a minus, making this a plus. You see the plus minus and minus plus right there. And then you've got your tangent of the 5 pi over 4, and times the tangent of that theta right there. Okay, so let's substitute and solve for tangent of 5 pi over 4. All right, tangent of 5 pi over 4. Picture the angle 5 pi over 4. That's quadrant 3 right there. And sine, tangent, remember, is sine over cosine. So sine would be negative root 2 over 2, and cosine would also be negative root 2 over 2. So that's just a 1. Oh, how nice. All right. And then I've got minus negative 1/3. I bet you I just did plus 1/3. Yes, I did. And then 1 plus. And the tangent of 5 pi over 4 is still 1. And the tangent of theta was given as a negative 1/3. Okay. Now let's clean both of those up. So do you see in your numerator a 4/3? And do you see in your divisor a 2/3? And wouldn't those divisors of 3 cancel right there, leaving us 4 over 2? And 4 divided by 2 is 2. So that's number 6. Nice. Okay, number 7. If tangent of alpha is 4/3 and tangent of beta is negative 1/2, let's show that tangent of alpha plus beta equals tangent of pi minus beta. Well, this is almost like a proof right here then, but essentially all we have to do is show that these two sides are equivalent to each other. All right, so let's work both sides one step at a time. And again, there is my sum and difference formula for tangent. Tangent of alpha plus or minus beta equals tangent of alpha plus or minus tangent of beta over 1 minus plus tangent of alpha tangent of beta. So looks like we're going to work this left-hand side. So tangent of alpha plus beta. Now, I don't know if I substituted immediately. I'm thinking of this first term right here as tangent of alpha, or you could go right to the 4/3. I went right to the 4/3. And you see the plus here. I'm going to need a plus right there. Okay. And then I have my tangent of beta, which is the negative 1/2. Okay. Over 1 minus, and then I have tangent of alpha times tangent of beta, which would be 4/3 times negative 1/2. Okay, so we'll simplify that in a second. Let's play with the other side. Okay, so same thing. Let's use tangent of alpha minus beta. So I'm going to go tangent of pi. Oh, it looks like I'm going to substitute right away too. So here's pi right here. Oh, I see, because tangent of pi, well, tangent is sine over cosine, and sine of pi is 0, so tangent of pi is just 0. Okay, and then a minus the tangent of the beta, which is negative 1/2. Okay, I like that. All right, now over the 1 plus, okay, and then tangent of alpha times tangent of beta. Well, tangent of that pi is still 0, and tangent of the beta is still negative 1/2. All right. Now let's clean up each of these. So the left-hand side. Wow, that's kind of ugly. Well, let's be careful here. So I have a common denominator of 6. So is that 8 over 6 minus 3 over 6, which would be 5 over 6? And then down here I have this negative 4/3 times negative 1/2 would be positive 4 over 6. So 6 over 6 plus 4 over 6, that's a 10 over 6. Okay, all right, let's clean up this one. I see a 1/2 up top and just a 1 in my divisor, so that's just 1/2. All right, and I'm hoping 5 over 6 over 10 over 6 is 1/2. Well, the 6's would cancel, and you have 5 over 10, and 5 over 10 is 1/2. So just like a proof, we work both sides independently. So let's throw a little QED in that one. All right, that's awesome. Okay, number 8. Find the angles formed by the intersection of y equals 2x plus 1 and y equals 4 minus 3x. Okay, now let's remember, we came up with a formula. In fact, we use tangent of alpha plus or minus beta to come up with a formula for the angles formed when two lines intersect in the plane. Okay, so let's bring back our formula. It was tangent of theta has to equal the slope of the first line minus the slope of the second line over 1 plus the product of those two slopes. So that's simple. So the angle theta that we're looking for, tangent of theta would be, well, let's subtract the slopes, and it doesn't matter which one we call the first and the second. So I'm going to go 2 as my m sub 1, and then minus -3. Can I just write that? Plus 3. All right, and then 1 plus the product of those two slopes, which would be -6. So that's 1 plus -6 or 1 minus 6. All right, and let's clean that up. I see a 5 over a -5. That's a -1 right there. So when does tangent have an output of -1? Well, let's visualize right here. Okay, tangent has an output of -1 either in quadrant 4 right here or quadrant 2 up here. Okay, now quadrant 4, all right, and this is the angle. My calculator would give me a negative angle right there, because remember the restricted domain of tangent is -pi/2 to pi/2, or in degrees, -90 degrees to 90 degrees. All right, so that would be like a -45 degrees right there. Now, I don't want the negative angle because we're talking the angle formed by two intersecting lines right here. So what I want is the quadrant 2 angle right there. All right, and isn't that nothing more than 135 degrees? So this angle right here is 135 degrees. And then by the angle sum theorem right there, these two angles would have to add up to 180. So doesn't that make this angle right here 45 degrees? And there you go. So the angles formed by those two intersecting lines would be 135 degrees and 45 degrees. And of course, by the vertical angle theorem, you know that this angle then would be 135 and this angle would be 45 up there. Okay, number 9. Suppose angle A is acute and cosine of A equals 4 over 5. Let's draw that. And I'm going to draw angle A is acute. So I'm going to draw a quadrant 1 right triangle. There's my angle A right there. And they said cosine of A is 4 over 5. Well, cosine, right triangle trigonometry, is adjacent to hypotenuse, making this leg a 4. And the hypotenuse of this right triangle a 5. And this is not drawn to scale, but this is a Pythagorean triple, and this would have to be a 3 right here. Okay, so there we go. And now it simply says find sine of A. Well, sine of A, SOHCAHTOA, sine is opposite to hypotenuse, 3 over 5. Oh, nice. Okay, number 10. Oh, same thing. Suppose angle A is acute and cosine of A is 4 over 5. We have that diagram already. There it is. And now we're finding cosine of 2A. All right, so remember our double angle identity for cosine? Cosine of 2 alpha is going to be, and we have 3 identities for cosine of 2 alpha. And you know what? I would use the identity that is in terms of cosine because that is the given. Although with this triangle, you could use any of the 3 identities. So I bet you I did 2 cos squared of alpha minus 1. Yep. So that equals 2. And cosine of alpha, well, cosine of A is 4 over 5. If I square that, I get a 16 over 25 minus 1, or 25 over 25 if you like right now. And now let's just do our arithmetic. So do you guys see 32 over 25 minus 25 over 25? Yeah, I'm going to go common denominator there. And 32 minus 25, that's going to be a 7. So cosine of 2a is 7/25. Oh, that's so powerful. Number 11. Suppose angle A is acute and cosine of A is 4 over 5. Oh, same diagram, right? And now they want sine of 2a. Well, we don't even have to think about which identity to use because there is only one. So we're going to go sine of 2 alpha is 2 sine of alpha cosine of alpha. All right, so that equals 2. And sine of alpha, well, that's sine of this angle A right here, would be opposite to hypotenuse, that's 3/5. And cosine of that angle A would be adjacent to the hypotenuse, which is 4 over 5. And let's just do our arithmetic. Do you guys see 2 times 3 times 4 as 24? Over 5 times 5, 25. Nice. All right, number 12, simplify. Okay, here we go. Now, I love simplifying now when we have all of our identities, these double angle identities. Let's just apply them and see how this cleans up. So, oh yeah, don't panic. It's okay, because you know what sine of 2x is. So we're going to go, bam, and isn't sine of 2x 2 sine of x cosine of x? Yeah, and let's go 1 minus. Now here's where you get really strategic, because aren't there 3 identities for cosine of 2x right here? Now, which one would we use to do the most simplifying here? All right, I think I'm going to use my favorite, because I have a 1 minus, and wouldn't it be great if I had a 1 right here that could cancel with the 1 outside of the grouping symbol? So can I go cosine of 2x is 1 minus 2 sine squared of x? There we go. And I hope you see right now why I did that. So right here, let's just clean up our divisor. 1 minus 1 is gone. And then I have minus a negative 2. That's 2 sine squared of x. And now let's simplify. 2's cancel. Factors of sine cancel. And I see a cosine of x over sine of x. And isn't that cotangent of x? There you go. Good stuff. Yeah, Einstein's loving that. He is saying right now, with all your identities, this stuff is a piece of cake. All right, let's do another one like that. That was too much fun. Okay, so now, oh, this one looks a little tougher, but we have identities for this stuff too. I know, it's been a while. 1 plus tangent squared of y. Isn't that one of my Pythagorean relationships? Yeah, no panic here, because we can go 1 plus tangent squared of alpha equals secant squared of alpha. So how about we go secant squared of y? Yeah, see it right there. All right, and then cosine of 2y. Yeah, we have identities for that one. In fact, we have 3 of them. Which one are we going to use? Well, it'd be great if we could get rid of this minus 1. So how about we go the 1 minus 2 sine squared of y? Yeah, and then minus 1. Now do you see why I did that? The 1 minus 1 is now gone. So let's clean this up. Yeah, all gone right now. Oh, yeah. So now we've got negative 2 sine squared of y. And that secant squared of y. I know what to do here. So secant squared of y. And then let's put the negative out front. And then 2 sine squared of y. And then remember your reciprocal relationships. What is it? Isn't secant of y 1 over cosine of y? So you know what we're going to do. The secant squared of y, we're going to put as 1 over cos squared of y. Just like that. And then you all know sine squared over cos squared is tangent squared. So this is nothing more than negative 2 tangent squared of y. There you have it. Again, yeah, we're liking that. Oh, that is it. I was having so much fun too. All right, you guys, now you make sure you go over these problems, and when you come to class, we're going to answer any further questions you guys have. All right? And I hope everybody has a great day. And I hope you're having as much fun with this stuff as I am. Thanks.